let's talk about heat and specific heat and how they are different from temperature. Heat is a form of energy. It is not the same as temperature. Temperature measures the kinetic energy, which is one of the forms of energy that we'll be looking at. But heat is just a form of energy. Heat is measured in the unit of calories. 1 calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. A food calorie is actually what we call a kilocalorie. It is 1,000 times larger than a scientific calorie. So we'll talk a little bit more about how heat is used in our diet. As I'm sure you know, we do need to eat food. We do need to have some calories in our diet. The reasons we need calories are to make our muscles work and to keep our body warm. Those are the two basic functions of calories and food. We can't make anything work without some calories. We need energy to do all of the processes in our body, and we need energy to keep our body warm. We're going to focus on the keeping our body warm for the moment because that is a big part of our basal metabolic rate. Our basal metabolic rate is how much energy it takes for us to just lay in bed, not do anything. First, let's break down how a calorie is used. Again, the definition of a calorie is the amount of energy required to raise the temperature of 1 gram of water by 1 degree Celsius. So we'll start with this one container. We're going to have 1 gram of water in it. We're going to raise it by 1 degree Celsius. That will cost us 1 calorie. If I take this container and it has 10 grams of water in it, and I raise it 1 degree Celsius, that will cost 10 calories. Now if I have this other container and it only has 1 gram of water in it, but I decide to raise it by 20 degrees Celsius, that will cost 20 calories. So as you can see, the amount of calories required depends on two things: how much mass there is and how much the temperature needs to be raised. So if I have 1 kilogram of water, that will cost 1,000 scientific calories, or what we would call 1 food calorie in the dietary system. If I have a 50 kilogram person and they need to be warmed by 1 degree Celsius, it's going to take 50,000 science calories or 50 dietary calories. And if I have a 100 kilogram person being warmed 1 degree Celsius, we'll see that it should take 100,000 science calories or 100 dietary calories. But that all assumes that the body is made up of 100% water, which it isn't. But this gives you the idea that doubling the mass takes double the amount of energy to keep the body warm. Now let's look at how the external temperature affects the calories needed. If we have a temperature of 5 degrees Celsius outside, and we want to warm it up to around body temperature, let's say 30 degrees Celsius, the difference is 25 degrees Celsius. If you have a 100 kilogram person, and you warm them up, assuming it's all water, by 25 degrees Celsius, that would be 2,500 food calories. And if it was a hot day, and it was already 25 degrees out, and we needed to warm the body up to 30 degrees Celsius, that's only 5 degrees Celsius change. That same 100 kilogram person would only use 5,000 calories to keep their body warm. So as you can see, a cold day makes you burn more calories than a hot day, and being larger also burns more calories. This helps to explain why when you're dieting, as you lose weight, you have to cut more and more calories from your diet or increase your exercise over time so that you can continue to lose weight, because at your lower mass, you need fewer calories just to stay warm. Now these assumptions, we're using water as our number. Obviously the numbers will be different depending on if there's fat or muscle. We're going to talk a little bit about how that is affected on the next section. Now we're going to talk about specific heat. Specific heat is the number of calories required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Specifically, we see that water has the specific heat of 1 calorie per 1 degree Celsius. That's because a calorie is defined as the amount of energy required to heat 1 gram of water by 1 degree Celsius. Notice that we see different numbers for air, glass, copper, and platinum. All of these take less energy to heat. So water takes 1 calorie per gram degree Celsius. Air only takes 0.3 of a calorie per gram degree Celsius. Glass takes around 0.2, and metals are around 0.01. They take a lot less energy to heat up a metal than it does glass. And you'll notice that when you're heating up food and things like that, we'll see that water takes a lot of energy to heat up compared to the metal pot that's around it. For example, if we had the same mass of metal and water, and we added 100 calories of energy to each of them, we would see a difference in the amount of the temperature of those two substances. Specifically, if we had 10 grams of water and we added 100 calories of energy, we would see that the temperature would rise up by 10 degrees Celsius. On the other hand, if we had that same amount of metal, so 10 grams of metal, we add 100 calories of energy, because the specific heat is only 1/10, we would see that the temperature would go up to 100 degrees Celsius. So again, same mass, same amount of energy, different specific heat. It takes less energy to heat the metal, so with the same amount of energy, the metal's temperature will rise much faster. Let's see how this affects our day at the beach. When we go to the beach, the sun is beating down and we can look at different temperatures. So think about when you go to the beach, if you're walking on the asphalt or on the sand or in the water, or if you touch your car or the car window. What do we see and what do you feel? So let's say it's a 90-degree day at the beach. If you walk on the blacktop, you're going to burn your feet because it's going to be very, very hot. Then you walk on the sand and it is still quite hot. You run into the water and you cool off. Notice that it is much colder than the air and the sand. That is because of the high heat capacity or specific heat of the water. We come back out, we go back to our car, you touch the car in the window and you'll see that they are also quite hot. So let's see, which one do you think is the hottest? Here we can see that the metal, like the car, is going to be around 0.1 calorie per gram degree Celsius. The sand and the glass on the car are both made out of silicon, and so their specific heat will be around 0.2 calories per gram degree Celsius. And the air is around 0.3 calories per gram degree Celsius. And finally, the water has a specific heat of around 1 calorie per gram degree Celsius. To get an idea of what this means, it takes about 10 times as much energy to heat up the water as it does to heat up the metal on the car. And it takes about 5 times as much energy to heat up the water than it does to heat up the glass windows on the car. And it takes about 3 times as much energy to heat the water as it does the air around. Which tells us that on our sample 90-degree day, the water might only feel like it's 75 degrees, and the sand might feel like it's 110 degrees, and the car might feel like it's 120 degrees Fahrenheit. The specific heat of various substances can also have an effect on our environment. One of the most common things that we can see is the effect of water in the air, what we call humidity. Certain areas, like swamps and rainforests, have very high humidity. And you'll notice that when you look at their temperatures and their day and the evening temperatures, you'll find that the temperature remains fairly consistent. That's because, while it takes a lot of energy to raise up the temperature, once the temperature is hot, it's very hard to cool it back down because all of that energy has to be released to something else. On the other hand, when we go to the desert, we can often see that there is a large fluctuation in the temperature. Sometimes it can be over 100 degrees Fahrenheit in the daytime and below 32 degrees Fahrenheit freezing at night. That's because as the sun is shining down, it readily supplies plenty of energy to raise the temperature. But once night hits, there's no more energy being added and the energy is lost because there's no
water in the air to hold on to the energy. And that partially explains why sometimes you'll say, at least when it's hot in California, it's a dry heat. That's because it doesn't take as much energy for us to cool off. You may have noticed that when you're in a steamy situation, you feel worse because all of that heat is trapped on you with that water. If you have something called evaporation occurring, it actually cools you off, which is how normally sweating cools us. In dry and desert areas, when we have dry air, it's much easier to be cooled by our sweat. But in areas of the south and the tropical rainforests, we see that we don't cool off as much because that water can't evaporate off of our surface. Well, it's fairly easy to see that humidity has an effect on our climate. We will also see some microclimates, and we're going to talk about that next. Here we're going to look at two areas of Southern California, both in the desert. We're looking at the beach and in the valley.
These two areas are about 30 miles apart from each other. What I'd like to focus on here is the variation in temperature in the summer. So we'll notice that in the valley, the temperature rises to 90 degrees in the daytime, and it goes down to about an average of 64 in the evenings. Whereas at the beach, 30 miles away, we see that the temperature only rises to 76 during the day and stays more consistent at 63 degrees Fahrenheit in the evenings. What we can see here is that there's a lot more water at the beach, obviously because of the ocean, and that keeps the temperature much more consistent. We don't see a huge variation in temperature because the water absorbs much of the energy that is beating down on Earth in the area of the beach, keeping the area much cooler. In the valley, it is more like an average desert, and we see that it rises and falls much more because there's no water to absorb that energy.